Hi everyone. So here is the second part of this lesson on optimization word problems. So pause and try the do now. So it says f is continuous on the closed interval and has values that are given in the table. F of x must have at least two solutions. This is a pretty old problem, I would say. I don't think they really ask this very much anymore. But it's not very hard. So we have 0, -1, and then 1, 2, -2. For this to have two solutions as in it crosses the x-axis, at 1 it has to be above the x-axis, right? So that it has 2. At 0.5, at 0 it would have 1, and at all of those it doesn't have to have anything. So that's basically the intermediate value theorem. You don't see much like this anymore. Okay, so just a key thing to remember with optimization is we're optimizing. We're finding a maximum or a minimum, usually a maximum, sometimes a minimum. So to find a max or a min, we take the derivative, set it equal to 0, and I typically will use the second derivative test to confirm that it is a max or a min. Although honestly, typically these just work themselves out, so I don't worry too much about it. Okay, a rectangle is inscribed in a semicircle of radius 2. Find the dimensions of the rectangle that has the maximum area. So this is like the sign problem. So pause the video, draw yourself a picture, and see if you can figure it out. So we have a semicircle of radius 2, and then we have a rectangle inside of it. This one I think is actually a little easier than the sign problem. However, a lot of calc kids in the beginning forget the equation of a semicircle. So the equation of a circle equals radius squared, so 4. So when you solve for y, you get the square root of 4 minus x squared. So that's the equation of the circle, right? So like if we're talking the height, that again would just be 4 minus x squared. So the area of a rectangle is length times width, so that's my width, say. So now what would this distance be? Well, if this is x, right, this point would be x comma the y, square root of 4 minus x squared. So if that's x, what would this point be? -x. So this whole distance is 2x. So our function, you want to put a for area, you can, is the length is 2x times that square root, the height. So this is the function we're maximizing. Take the derivative, 2 root 4 minus x squared plus 2x times the derivative of a square root is 2 times 1 over 2 times the square root, and then the derivative of the inside, -2x. Now this one is a little more difficult to solve. I'm going to cancel those out, set it equal to 0. So we get minus 2x squared over 4 minus x squared. So I need a common denominator. So I'm going to multiply that left fraction by the square root. So we get 2, the square root cancels out. Now I'm not going to worry about the bottom because the 2 and the -2 are going to be over here. So it's really the top that we're setting equal to 0. So I'm going to distribute, and I get 8 minus 2x squared minus 2x squared equals 0. 8 minus 4x squared equals 0. So x squared is 2. X is root 2, plus or minus. If we took the second derivative, we could then check, but I'm pretty confident in my answer, so I'm not going to do that. So let's see. What is it asking for now? Find the dimensions. So the dimension would be 2 root 2. And then the height, if I plug in root 2 here, that ends up just being root 2. So then the area would just be 4. Okay, again, here is the method in general for solving these. Again, this isn't 100%. Sometimes you're just creating a function and you don't have to do a substitution, but it's pretty common. So we write an equation that has multiple variables, so an equation. We create a function that is going to give us our max or a min. We substitute into our function so that we only have one variable, differentiate, set it equal to 0. All right, so this one is very similar, is using that method, right? A manufacturer needs to produce a cylindrical container with a capacity of 1,000 centimeters cubed. The top and the bottom of the container are made of material that costs 5 cents per square centimeter, while the side of the container is made of material costing 3 cents. Find the dimensions that will maximize the company's cost. So what is our equation? Well, they're giving us a volume formula. So 1,000 equals, what's the volume formula for a cylinder? Pi r squared h. And then I'm going to think, what's easier to solve for? H. So my guess, again, not 100%, but I'm pretty confident in my knowledge, is that I'm going to have to substitute in for h so that I only have one variable. Okay, so now let's talk about the material and how we find the cost. So here's my cylinder. So the top is made of a specific material that costs 5 cents. So we need what of the top and the bottom? We need area. So it's a cylinder. The area of a circle for the top and bottom is pi r squared, but there's 2 of them. So we have for the top 2 pi r squared times the cost, 0.05. And then that's top and bottom actually. And then for the part going around, how do you find that amount? So this is surface area, right? So how do you find the amount of material used on around this thing? So that's surface area. So it's the height, h, times the distance around. All right, so the distance around, we'll call it that, is 2 pi r. That's the circumference times the height, right? And then how much is it costing to make that part? 0.03, right? So the cost of the entire can, or whatever it is, let's see, 2 times 0.05, so 0.1 pi r squared plus 0.06 pi r h. But like I said before, we don't want both r and h in the problem, so I'm going to replace my h with this. So we get 0.06 pi r, and then I get 1,000 over pi r squared. So the pi's cancel, that r cancels. 0.06 times 1,000, let's see, 1, 2, 1, 2, so 60. So 0.1 pi r squared plus 60 over r. All right, that's my cost formula. Take the derivative, set it equal to 0. 0.2 pi minus 60 over r squared. Oops, r. Set that equal to 0. 0 equals, I'm going to turn that, so we need to multiply by r squared here. R squared, So 0.2 pi r cubed minus 60 over r squared. So now I'm going to set the top equal to 0. So we get 60 equals 0.2 pi r cubed. 60 divided by 0.2. 300 equals pi r cubed. So r is the cubed root. Please excuse that tiny little 5. 300 over pi. Let's see. Find the dimension. So I would say, because it's a real world problem, we would want the actual number here. So this cubed root of 300 over pi is 4.571. Find the dimensions that will minimize the company's cost. And so then h would be 1,000 divided by pi, and then that answer squared. Put that in my calculator, and I got 1.524. Just kidding, I typed in my calculator wrong. I put 100 instead of 1,000, so it should be 15.236. Right, and those are my dimensions. All right, last one. I thought this one was pretty tricky, but I've had students in the past who figured this out super fast. This one took me a bit because the whole idea of the amount of people. So it says you operate a tour service that offers the following rate: $200 per person if 50 people, the minimum number of people, go on a tour. For each additional person, up to a maximum of 80 people total, the rate per person is reduced by 2. It costs $6,000 plus $32 per person to conduct the tour. How many people does it take to maximize the profit? So I want you to pause and see if you can figure out this equation. I'll be impressed if you can, because I honestly found this quite difficult. But again, a lot of you are smarter than me, so. Okay, so x, I'm going to let x be the number of people above 50. And that's where what I think was difficult when I did this the first time. If you ignore that fact, you get like 42, I think. But we need to have above 50. So the cost, right, is going to be, like, think about what we're making. So we're making $200, right? But we're going to minus off $2 per person above the 50. And then times the original 50 plus x. So that's the amount that we're making, right? $200 reduced by that 2, and then times the number of people plus x, because we're above 50. And then, so that's how much we're making, and then we have to subtract off the $6,000 and subtract off the $32 for every person. Again, 50 plus x, the original 50 plus the extra. So that's my equation. So now we're going to go through, multiply it all out. So I FOILed this, and I got 10,000 minus 100x plus 200x minus 2x squared minus 6,000 minus 1,600 minus 32x. Combine like terms. Negative 2x squared. Then I got that and that, which gave me 68x. And then I got 10,000 minus 6,000 minus 1,600, which gave me 2,400, sorry. So the cost, now I'm going to maximize, right? How many people does it take to maximize profit? Take the derivative. set it equal to 0, and I got x equals 17. So that's not the total number of people though. That's the number of people above 50. So a total of 67 people to maximize. So I thought that was tricky, figuring out the subtraction and the adding and everything. So, all right, that's all I got. All right, there is your homework. Have a fabulous day. It's only 4. The other homework I think had 5, so it shouldn't be too terrible. I would say take a day before you get it all done. Don't try to do it all in one night.